Welcome back to the Ductile series of instructional videos. In this video we're going to talk about some of the basic material properties of steel. Now, steel is a precious material. It's a result of an intensive process that starts with quite large operations to extract the raw materials from the ground. And it is an energy intensive process to make the material. It does need to be melted down and refined over a series of steps, and in order to get it to the final profiles, it does need to go through quite a number of processes. Sometimes they involve a lot of energy and heat, depending on the thickness of the material that's being worked with, and this progressively is worked through to thinner materials that rely on pressure alone to make the profiles. Now, in order to get the heavier structural steel, which has thicker flanges and I guess heavier weight steel, we need to use heat in order to sort of make the steel, molten steel, more malleable and to push it into the shapes. So in the furnace, the molten steel is then cast into smaller ingots and then drawn out into, I guess, the preliminary sort of raw form of the steel, which is then processed either into a series of plates, and then it's pushed through die and different heavy pressure rollers to construct a series of profiles. Now, these heavier steel with thicker flanges is the result of a process called hot forming or hot rolled steel. Now, the thinner base steel, which is used for lightweight partitions and so on, is a product of thinner base metal, which uses just pressure alone and not necessarily heat to make the various profiles. Now, the irony of steel is that we always call it a light material, but in fact the mass of steel is very heavy. Compared to wood at 950 kilograms a meters cubed, steel at 7,850 kilograms is a heavy weight. Even concrete at 2,400 kilograms per meters cubed is much lighter than steel. However, the thing is, we don't use steel in such large quantities, and the property of steel is that it's got a very impressive strength to weight ratio. We can get long spans and the material is very stiff. Its ability to resist deflection is much greater than timber and just unreinforced concrete and also reinforced concrete. Its capacity to bounce back under sort of plastic deformation is greater than any of the other materials, and we get to a point where even beyond that point where a steel member is pushed to an excess amount of load, it will continue to deform and work structurally until it reaches its ultimate strength, where it will fail. So the stiffness of steel is approximately 10 times that of concrete, and it's also like compared to wood, like aluminium is about 2 times stiffer than wood, and steel is 3 times stiffer again than aluminium. So its capacity to resist plastic deformation means that we can use quite small sections of steel to span quite long distances and to carry heavy load. Now, part of the issue with that is that slenderness becomes an issue, and the corollary of that, which is the propensity for the element to buckle under pressure that's being pushed on it from the ends of it. Now, the stiffness of a material, well, I guess the slenderness, sorry, of an element is a product of its cross-sectional area in relation to its length. And so with steel having much smaller cross-sectional areas, than either timber or concrete, this slenderness ratio does become an issue. And it's where things like the effective length of a steel member becomes much more into play. So although a steel element can be quite long and span quite a long way, often we need to reduce its effective length by pinning it back to a rigid structure to reduce the overall effective length and to reduce its propensity to buckle. Now, as we said in the leading instructional, steel is a prefabricated system, and the reason for that is it is just a difficult material to work with. It involves heavy machinery and grinding equipment, and these types of processes are very difficult to do on the work site with anything larger than simple merchant bar. The other issue is that corrosion is, I guess, one of the steel's biggest enemies. So the typical corrosion is reaction to oxygen, and in normal circumstances all steel will rust. Here we can see what's called black steel, which is untreated steel pipe exposed to the air, and it's surprising how quick the corrosion will affect the steel. Now, other environmental aspects such as proximity to the seaside with more salt in the air, and also soils which are more acid sulfate will also enhance the corrosive capacity. The other thing that is also a bit of a problem is galvanic reaction, which is I guess enhanced degradation or oxidization of material as a result of the chemical reaction of dissimilar metals, and that's a common mistake made in detailing. The other issue with steel, of course, is its performance in fire. So the yield stress of steel under normal temperatures is quite good. However, as the temperature gets higher, that yield stress drops off very quickly. So for multi-story and for structural applications where contained fires will be an issue, we do need to treat the steel in a way to resist or to protect it from high levels of heat, so that the building remains stable long enough for people to escape from it. The typical ways of treating steel to resist fire is to encase it, and typically this is either done through encasing it in concrete with a minimum thickness to ensure a certain barrier to the steel. We can use sheeted pre-engineered systems of multi-layers of gyprock or plasterboard or gypsum board material, and if it's done well enough, the fire resistance of the gypsum board will protect the steel long enough for people to evacuate in a fire. The third one is coating the steel with a special intumescent paint. Now, this intumescent paint is a high build surface finish. It comes in a limited range of colours, and it's not a very aesthetically pleasing finish. It can be used for some structural steel in exposed situations, but typically in very large buildings like airports and stadia and so on, where the steel is quite a distance away from normal vision, so the actual visual appearance of the intumescent paint is not noticed. Now, the way that the intumescent paint works is that it expands dramatically under response to heat. So as the intumescent coating expands and fizzes, it creates a barrier around the steel that then helps insulate and protect the steel from fire. And the other aspect of steel is the other extreme, where absolute or extreme cold has the capacity for steel to fail. Now, it's very difficult to protect against that, and there are certain instances where freezing rain and very specific environmental conditions have brought down like power lines and other infrastructure. As I said, it's very difficult to combat this, but the other extreme of cold will also cause steel to fail. Well, that finishes this video specifically about the material properties of steel. Hopefully you've got something out of it, and you'll have a go at the other videos where we'll cover some of the more structure types and connection systems. Thanks for listening.